Alright guys, welcome to your first lesson in geometry. So we're just going to go over some basics here with points, lines, and planes, and then you've got two IXLs to take care of. The first one you should be able to get to 100. It should be a breeze. It's pretty straightforward. Get double points the whole way through. So it shouldn't take long. And then the second one is a little bit more of a conceptual IXL. Do you understand the concepts of how these things interact and play together? So we'll talk a little bit more about that when we get there. Let's just start by talking about points, lines, and planes. Now, there are some definitions here, and you can pause the video at any time you want to write down these definitions if you want to. We don't have notebook checks, so when we're doing this, it's not like I'm going to go and take a look at what notes you have. If you don't want to take notes, that's totally up to you. You should probably practice some of these as we go through them, because when we get into like the points, the lines, the segments, things like that, it's not just knowing the definition, it's knowing what it looks like and how to, what we'll say is notate it. So how do we write this? How do we write this out when we're kind of trying to express this thing? So, and you'll see when we get there. So let's start with a point. So a point is an exact location. So it looks something like that. And a lot of times what we'll do is we'll put a capital letter, like A or B. And that should be exactly what we think it is, right? Now, when we talk about a line in geometry is a little different than maybe what you have thought of in the past as a line. A line can actually be expressed in terms of points. It's all the points that extend indefinitely or infinitely in opposite directions. Sorry, yeah, infinitely, not indefinitely. And so a line, when we think about lines, a lot of times we think about something like this. We think of something, you know, that's straight and has two ends. But really a line, when dealing with geometry, has two arrows on the end because lines actually go on forever. And so when we're talking about this stuff, let's also think about dimensions. Remember what dimensions are. Hopefully you've run into dimensions before. So one dimension is like this line. This is 1D or one dimension. All right, it's got length, but it doesn't have height. It doesn't have depth. Now a point is actually 0 dimensions. Okay, it's 0 dimensions because it has no height, depth, or width. Now, when we get to segments, a segment is a part of a line that has 2 endpoints. And so the difference here between a line and a segment would be something like this. The segment is usually actually what we think of when we talk about lines. We're actually usually talking about segments. Now, how do I go about talking about these two lines? So if I'm talking about a line, let's put this as C and this as D. And actually, let's use the same letters. How could I determine that one's a line and one's a segment? Well, what we do is when we're dealing with lines, we would call this CD. And then over top, I'm going to put some arrows up here. CD with a line on top, whereas this is CD with a little segment on top. And so notice how these tell us what type of thing we're dealing with. Are we dealing with a line or a line segment? Now we could put a third point on here. Let's call this CE, CED. Now there are other ways. If I have more than one or more than 2 points on a line, I could call this CE. I could call this, you know, ED. I could call it DE or EC. As long as I have two points on my line that are in my notation, I'm good to go. Now let's look at this. What if I put point E here? Is CE the same as CD? Well, they're not the same because CE goes from this point to that point, right? CD is the whole thing. Whereas with my line, I can pick any two, and the reason I can pick any two is because it has the arrows. It's not just C to E, it's everything on either side of C and either side of E. So we're dealing with lines and line segments. Those are some things to be on the lookout for. Now, there is a third one-dimensional thing that we need to talk about, object we need to talk about, and that is a ray. Now, a ray is kind of like if a line and a segment got together and had a kid, you'd end up with a ray. It's got one endpoint call this F. We'll call this G. It's got one endpoint, and then the arrow goes off on the other one. And so it goes on infinitely. It does, but only in one direction, not in both directions. And we would call this, if you're thinking this through, you should be able to think this out. FG would be the name of my ray, and I would put a ray right over top. Now, there are a couple places where this sometimes gets a little bit confused. Notice that F needs to be at the end of my ray. If I put another point here, we'll put H. If I put HG, is that the same ray as FG? Well, it's not, because if I do HG, I start here and I go that direction, and I actually miss out on this FH part. But what if I do FH? Is that the same ray as FG? Well, it's everything between F and H, and then everything past H, so that actually would be the same ray. Now, could I put, so that would be, it's not the same, that is the same. Let's try GF. Is that the same ray? Well, no, because this one would be implying, and sorry, my handwriting's a little messy here, this would imply that we start at G and we're heading this direction. The arrow at the top doesn't tell you which direction the ray is going, it's just saying it's a ray. So, for example, I could have a ray going like this. This is IJ. That ray's name is still JI. You always start with the base or your endpoint and then work towards your infinite side. So it doesn't matter which way the ray is going, we're always going to notate our rays with an arrow to the right. Now here's a couple terms that we should be familiar with. Intersect, that's where things cross. You can think of an intersection where two roads cross. If you're doing your driver's license and stuff, or permit, you've got to learn about intersections. Bisect gets confused for intersect. Bisect means we're cutting something exactly in half. And notice it does have that kind of the sect of, intersection where we're crossing. But notice bi is like bicycle, or two things, so you're cutting something in half. Bi is two, so it's cutting it perfectly in half. So do keep an eye on bisect versus intersect. These should be pretty straightforward. The midpoint, it cuts really, I should say, line segment in half, because you can't cut a line in half, so that actually should have the word segment right there, line segment. And then the end point is the last point on a segment. It's the end. Those should be pretty obvious. So let's take a look at a few other things besides just rays and points and lines. What happens when we start combining some of these things together? So collinear means points that lie on the same line. And if we think about this, this word should make sense. We've got this word linear here, and then co. Anything about co, like co-workers, you're working together. Linear means you're on the same, you're on a line, right? Linear and line. So collinear means together on a line, or points that lie on the same line. So in this picture here, we have A, B, and C would be considered collinear. The point D would not be considered collinear. Now, a plane is a flat surface that extends indefinitely. Probably the most common place where we think about this would be something like a sheet of paper. With a sheet of paper, you've got two dimensions. You've got height and width, but there's no real depth to the paper, right? And I mean, technically there is with paper, but the idea here being there's a pretty good example of what a plane is. So coplanar just means that we have points that lie on the same plane. So again, it would look something like this, where we end up with A, B, and C all being on the same plane. Now I could have an additional point. We'll say this pen, the tip of this pen would be a point. So if I had an additional point out here, this would not be coplanar, because we've got points here and then one out here. So coplanar means they're all on the same plane. Now, there's a few other things we need to talk about. What happens when we start combining lines with planes? And so parallel lines mean that the lines are on the same plane, but they never touch. And parallel lines are exactly what we think they are. Like, there are lines that look something like this, where I've got lines on the same plane, whereas perpendicular lines make right angles. And skew lines are two lines that don't intersect but are not on the same same plane. Oh, and with parallel lines, generally we put an arrow on the line at some point on the line, just to denote that these are both parallel lines, or they're parallel to each other. Skew lines are lines that do not intersect, that are not on the same plane. So let me show you some examples of what skew, parallel, and perpendicular lines would look like kind of in a 3D here, even though you're on 2D, you're looking at a 2D screen. So roughly, if I'm looking at parallel lines, I'm going to take these chopsticks here. These would be considered parallel lines because they're going in the same direction. Again, I know they kind of look like they point opposite directions, but they're parallel to each other, not intersecting. And if I wanted to, let's see if I can get a plane here to hold up for me. Let's say this paper is my plane. I could imagine, let's see, there we go, something like this, that they're going in the same direction, but also they are parallel. So now skew lines, and again, I'm trying to do this kind of 3D so you can kind of see skew lines. Maybe we have one line going like this, and we have a second line kind of coming this way towards, kind of towards the camera. And so you end up with two lines. They don't cross. Intersecting would be if they cross. They don't cross. They don't touch each other, but they also aren't on the same plane, so these would not be parallel lines. That's why we have to make the distinction. Normally we just say parallel lines don't touch, but there are other things. When we start thinking about the 3D of space, that's not just one plane. We have, depth to go along with our height and width. So we've got that to deal with. So now I can start thinking about lines and planes in different ways. And the second IXL, the first one's quite easy. It's just the basics. The second one starts asking some harder questions, like what happens if I get two planes and I intersect them together? Well, what actually ends up happening, you can kind of see where they touch. You end up with a line right here. That would be what would happen. But what if I got a line in a plane and I intersected a line in a plane? So here's my plane. Well, it depends on how I intersect it. Say this line comes in this way. Well, then that's an intersection of roughly a point on the plane, right? But what if it's intersecting like this, where the line is actually on the plane? Well, in that case, if I have a line on the plane, the intersection is actually still a line. So the second IXL asks you a little more conceptual-based questions. What happens when they cross? Or what happens if I take one thing and put it on the other? So it's trying to get you to take these concepts and to start playing with them. What happens when I'm thinking in 3D instead of just like on a piece of paper? My lines don't all have to be, the way I would think of a line. It could go, like this, or it could go straight, kind of out and back. So the IXL is trying to get you to think about those things. The first IXL, you should be able to get to 100, no problem. That should take about 5 minutes. The second IXL is probably more about 15 minutes, but again, if you kind of understand how these things are playing together, it shouldn't take too long. And if you get it wrong, they're going to give you a really helpful example picture of why you got it wrong, so it shouldn't take too long. So this wraps up our first geometry lesson on points, lines, and planes.